this is linear functions, graphing and interpreting. In this section, we're going to be doing a bunch of different things. Learning objectives are going to be graphing linear functions given an equation, interpret graphs, determine what the slope, y-intercept, and the x-intercept represent. A majority of this is going to be Algebra 1. Actually, all of this is going to be Algebra 1 material, but it's going to be a kind of a brief refresher. So these are the Indiana Academic Standards if you are interested. First thing I have to go through is y equals mx plus b, which is the slope-intercept form. This is something from algebra, and is something extremely important in algebra. And when you take geometry, or if you have already taken geometry, you talk about this as well. But the first part that's very important is this part right here, the m. The m represents slope. And slope is one of those things that, if you remember, m is equal to rise over run. That's a very important concept. Whatever your rise is, up and down, to whatever your run is, left and right. Your next thing that is important is the b. That is your y-intercept. Your y-intercept is also extremely important. The reason it's extremely important is because it represents your starting amount, your initial amount, wherever your graph actually starts. And it's associated with the b. So there we go. So some of the issues that I have is some people kind of forget what to do first. What do you do first is rise over run. This is kind of a mnemonic device to actually remember this, cartoon mnemonic device. So remember, you have to rise first before you can run. If you can run when you're on the ground, that's pretty impressive. But I can't, so yeah, good luck with that. All right. So let's jump into the academic part of it. So again, this is something that you have seen before, and I'm going to go through this relatively quickly. The first thing you need to remember is y equals mx plus b, where this guy here represents your slope. So my m is equal to 2 over 3. That means that's your rise, and this is your run. So if you rise 2 or go up 2, you will run or go left and right 3. And it can be left and right, it can be up and down in this case, and I'll show you why in a second. Second thing of importance is going to be your b value. So your b value is whatever is right next to the x. It's the constant number that's off to the side. This is -5. Now I asked this in my algebra class multiple times, and I still have people that mess it up, but I always ask what the point, the xy coordinate of the b value is, and it always is represented by your x value being 0 and then whatever your b is. And the reason that's important is because you're not going anywhere. Your x value is 0. It's the starting amount. So you haven't done anything yet, and when it comes to the business portion of it, you'll see why that's important. So in order to actually graph this, first thing you have to do is you have to graph the y-intercept. So I'm going to graph the y-intercept, which is right here. And from here, I have a rise of 2, so I go up 1, 2, and I have a run of 1, 2, 3. That's up and to the right. I'm going to do the exact same thing, going a little bit quicker. Up 2 over 3 goes here. Up 2 over 3 goes here. The thing that I tell people, it's important to plot all the points, especially when we get to piecewise functions. That's going to be extremely important. So I'm going to also do this in the negative aspect, because remember, a positive slope, you can also go down, which is negative, but that means you have to go to the left. So down, -2, and -3, you still are at a positive, because -2 over -3 still is a positive. And you continue that all the way down. Down 2, 1, 2, 3. And I kid you not when I say this, you want to make sure that you have a ruler when you are doing this. So please plot the lines with rulers. Do not try and freehand it, because usually when people freehand it, it looks horrendously bad, comically bad, very bad. So there we go, perfectly straight line, and that's my graph. So I'm going to go through this one a little bit quicker. So we have my m is equal to -3. My b is equal to +4, or the point 0, 4. always say this in my other classes as well, is what is the number that is always underneath if there is no number that is represented? And we say it's 1. So that gives us our rise over our run. So from here, again, I'm going to do the exact same thing. I'm going to start at my starting point, which is 0, 4, my y-intercept. And then I'm going to go, in this case, I have to go down 3, 1, 2, 3, and to the right 1 to get to this next point. And I'm going to continue that throughout the entire graph. So 1, 2, 3, to the right 1, 1, 2, 3, to the right 1. Notice I'm not actually counting it out with the arcs. That's just kind of for your visual representation. So that's that. Now I can also do, instead of doing a rise of -3 and a run of 1, I can also do a rise of 3 and a run of -1. That still evaluates to a negative number. So I could also go the opposite direction, which is up 3. 1, 2, 3. To the left 1. That is still a rise over run of a negative number. So 1, 2, 3 over 1. That brings me to here. But again, in the end, you want to make sure that when you graph a line, you want to have a perfectly straight line with a ruler. It's a little hard in terms of the electronics to do this to make it perfect, but it's a lot easier when it comes to your paper and pencil. And there you go. Okay, this next one I'm going to actually do in 2 different ways. The first way is what's called the cover-up method way, because this is in standard form. Now, I didn't talk about standard form here, but this is Algebra 2. You should know what standard form is. So cover-up. So if I have the cover-up method, what I do is I'm finding the x-intercepts and the y-intercepts. So if I cover this up completely, and I have -5y is equal to 10, and I divide, I get y is equal to -2. That's my y-intercept. That's what the cover-up method is used for. Okay, so that's one way. And then you're going to do the exact same thing with the other function, other part of the function. So I'm going to cover up the -5y. I get 2x equals 10. I divide. I get x equals 5, and that's my x-intercept. So now, if I were to plot these, my x-intercept is 5, 0. Remember, intercepts have 0 at one of the coordinate points, so the y-intercept is going to be the point 0, -2. Now, the problem with this one is, I mean, this is perfectly fine, and you connect the points to make your line and make sure that they're more or less pretty accurate. The problem with this one is that when we do piecewise functions, you're going to run into some issues because of the constraints that you're going to get. But we won't worry about that until we get to piecewise. So that's way 1. Way 2 is what I'm going to do is I'm going to isolate and solve for y. And I tell my kids in Algebra 1 to draw a line. The reason is that's a visual representation. If you're moving things, not collecting like terms, but moving things, for example, we have to move the 2x to the other side, so we have to make it negative. So these guys cancel out. We bring down everything. We got -5y equals. These are not like terms, so you cannot say it's 8x. That is incorrect. That is a mistake that I see all too often. So in this case, I'm still continuing this line. I'm going to divide by -5. Again, this is all Algebra 1. And what you do to one side, you have to do to every single part to the other side. So this guy goes away. Right here, we have 2 negatives. So what I'm going to do is I'm going to take and make it a positive. And we get y equals 2/5x minus 2. Now remember, you can go rise, so your m is 2/5, but just like we simplified, it could also be -2/5. That could be your m. And your b, we know, is going to be -2. The nice thing is I already have my b, my -2. But if I'm doing piecewise functions, Like I said, that's going to be in the future. I'm going to want to graph some more points. So I'm going to go down 2 to the left. 1, 2, 3, 4, 5. So I need to fix that a little bit. And I'm going to do the exact same thing. And we're done. So 2 different ways. Both are acceptable and using 2 different techniques. Okay, so this one, if you want to pause the video and try this one on your own, you're more than welcome to. I'm just going to kind of go through this. Now this one is kind of a tricky one because we have to isolate or solve or get everything away from y. This is something you spent a lot of time doing in Algebra 1. So what I'm going to do is I'm going to subtract 2x from both sides. Remember, you have to do the opposite of what's being done on both sides of the equal sign. So if that's the case, these guys go away. I bring down all my other parts here. I've got a positive 3y. I've got a minus 4. I've got an equal sign. I add the like terms because they both have x here, so I can actually add those. 1 minus 2 gives you negative 1 plus 5. Again, I'm trying to isolate the y's. So when I do that, I got 3y. These guys go away. Negative 1, x, if you want to put it, that's fine. If not, that's fine as well. But here, I'm going to divide each part, every part, all parts by 3, and I get my negative 1 over 3, putting that because of the rise over 1, plus 3, which is what it reduces to. So now, I have my slope I have to find, my y-intercept I have to find. My slope is negative 1 over 3, or 1 over negative 3. You don't have to put both of them, but just know you can go in 2 different ways. B is 3, or the point 0, comma 3. Again, knowing the points, the intricate details of this is going to be important. So I'm going to start off at 3. From here, I'm going to go down 1 to the right 3. 1, 2, 3. I could also go up 1 to the left 3. That's possible as well. But I'm going to continue this all the way through. Don't try and freehand this. That drives me insane when people say that I can draw a straight line and it looks horrendously bad. I have sort of an excuse because computer program is just slightly harder, but I get to fix it, which is kind of nice. So, and there is your line. For practice sake, we're going to do a few more. In this one, people get these mixed up. So what I tell people to do is to add a 0. If you don't see a y-intercept, put it as 0. And if you also want to be intricate, you can also put a 1 over 1 in front of the x. Kind of helps people when they're doing this. So 1 over 1 is your slope. You could also do negative 1 over negative 1. Remember, rise over run. They're both acceptable. And b is equal to 0. Your point is going to be 0, comma 0, which is your starting point, which is also called the origin. It's an important point. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and continue this on for what feels like eternity. Now I'm going to go down 1 to the left 1, straight line. Okay, these next 2 are special cases which you need to remember because you're going to be seeing these a lot. So if you just have one variable in your linear equation, this one here, if you guys remember from Algebra 1, is a horizontal line at 5. Now I'm going to make a mistake here because I see people, they go like this, and I'm doing this without a ruler for a reason. They go like this, and that's 5. No, that's not a horizontal line. Remember, horizontal is left to right. So that would be left to right. The sun sets on the horizon, so that means it's going to be left to right. It doesn't set up and down. It moves up and down, or at least it looks like it moves up and down. That's a science topic. So anyway, so in this case, what I do is I put a dot on the y-intercept because it's y equals, and then I take my perfectly straight line at y equals 5, and I draw it, and I'm done. Special case, horizontal, when you have y equals a number. Your next special case is x equals negative 3. So if you have x equals negative 3, that is a vertical line, which means I'm not going to go through the intricacies of the other part. Now it's at x equals, so that means it's on the x axis. And this one, again, x equals all the time. And there's your perfectly semi sort of straight line. Okay, so this is, again, where it gets to be important as well, because now this is interpretations in terms of the real world sense, because linear equations is one of those topics that you will actually probably use in life quite often. So when I say this, so we have the graph below shows the number of newspapers delivered and total pay for Leona's newspaper delivery job. It gives us the graph, which means that we have to interpret the graph. So it says, what is the slope and what does it represent? Well, if you're doing slope, remember slope is rise over run. And I'm going to go through this in a little bit more detail. But rise over run, you want to start at one point that actually occurs on the graph. What I see is I see this point that occurs where the grid lines meet, and I also see this point. So I need to find out how I get to those points. So what I do is I say, oh, okay, I'm rising 1. The problem is I'm not rising 1. We'll talk about that in a second. I'm going 1, 2, 3, 4 to the right. Problem is I'm not going 4 to the right. A big mistake that I see is people do not look at the scale factor. So I'm actually not rising 1. That's crap. I'm rising 5. Okay, so that's a plus 5. I'm actually not rising 4 because I'm going by intervals of 5. So I'm going 5, 10, 15, 20. You'd be surprised how many people put rise over run is 1 over 4 for this. It is not. It is 5 over 20. Now the nice thing is this actually does reduce to 1 over 4. That's not always going to be the case. You have to actually look and see what the intervals are doing on the graph. So that's the slope, that's your rise over your run, but what does it represent? So in this, the actual representation of it, if we know that it's 5 over 1, the representation of it is for every $5 that Leona pays, 20 newspapers are going to be delivered. So you could actually reduce that. For every dollar that Leona pays, 4 newspapers are delivered. So that would be the reduced slope. But again, don't just go on automatic pilot and say, well, it's going to reduce to 1 over 4, so I'm just going to go by ones in each direction. That is not the case. That will not always work. The next thing is, what is the y-intercept and what does it represent? Well, the representation is, that's your starting amount. It always will be your starting amount. And Leona has to basically pay $0 to actually start this whole thing off. So it does increase with time. And it doesn't ask this, but I'm going to put it anyway. But the equation for this line is 1 over 4x. Y equals 1 over 4x. And if you want to put plus 0 to indicate what the y-intercept is, that's fine. Okay, so the next interpretation, we have Colby put $100 into a savings account. The graph below shows how the amount in the account would increase over the next 10 years. People who work at banks, they have to interpret this type of stuff, financial records. So it is one of those things that is kind of important. In this case, what I do is, again, what is the slope? So I'm trying to find the slope. I do, again, a rise and a run. So in this case, we have a rise of 50 and a run of 9. So if I did a rise of 1 over 9, I would get this wrong because it does not reduce. So this is where the interpretation, you need to make sure that you go based off of the scale. So if this is the case, my rise is 50, my run is 9, and what does that actually represent? That represents Colby gaining $50 in savings for every 9 years that the account is in existence. What about the y-intercept? What is the y-intercept and what does it represent? Well, the y-intercept is where it starts. Right here is where the actual amount starts. Well, that kind of makes intuitive sense, commonsensical sense, because he put $100 in savings. So that's going to be the initial amount Colby invests, which is $100. So again, if I wanted to put this in y equals mx plus b form, it does not ask this. I'm just doing this just because of practice sake. You have your rise over run, your slope, times x, plus your y-intercept. In this case, your y-intercept would be 100. The cool thing is you can find out what's going to happen in 12 years, 15 years, so on and so forth. Okay, so your friends took you for skydiving for your birthday. Nice friends. So this graph depicts your adventure, whatever floats your boat. So here's the deal. What is the slope and what does it represent? But I'm going to introduce something that's something you might have not seen for a little while, is the slope formula. Just because. And yes, you can use this whole rise over run thing, which is completely fine, but I'm going to actually do something you guys need to know throughout this course because it's extremely important. And it's also an Algebra 1 interpretation. So what I'm going to do is I'm going to use the slope formula, which is first identifying what your x and y values are for each one of these points, and I'm going to find the slope. So we have y minus a y value over x minus an x value. You guys hopefully remember this from Algebra 1. What I'm going to do is I'm going to take and start off with any one of these points. It does not matter which one you start off with, but the direction that you go is going to be important. So for example, if I start off and go 21, 15, and subtract 2,500, I can't switch my direction in the middle of it, which means I have to go this to this. And I'm going to do the exact same thing for the y's. So in this case, I've got 35 minus 0. I can't do 0 minus 35 because I've already established the orientation. It comes out to a whole number of negative 11 over 1. And if you look at this, this is decreasing. It's going down from left to right. We read from left to right in America, in the United States. So this is interpreted as left to right. So what does the slope represent? Well, you drop 11 feet per 1 second. That's, yeah, interesting. So what is the y-intercept and what does it represent? Well, if you're skydiving, you have to start at a specific place. So what does it represent? It's the starting height, which is going to be 2,500 feet. Your y-intercept, remember y goes up and down, that's your y-axis, is at the 2,500 feet. What would the x-intercept represent? Well, if I'm continually falling, and this is your x-axis right here, so that's x-axis. If I continue this line all the way through, what would the x-axis represent? Well, that's when you would hit the ground. So when your y is equal to 0, or your height is equal to 0. Last but certainly not least, we have Charlie rented a moving truck. The equation below represents the daily amount Charlie paid for the truck if he drives it X miles. So I've already put the answers here. It says what is the slope and what does it represent? Well, for every mile driven, it costs 50 cents, which means that your slope is 1 over 2 or 0.5. The reason I put 1 over 2 is because it represents a rise over run. What is your y-intercept? Well, that's the amount up front to the company, so that means if you walk in the door and you're renting a truck, you have to hand them $10 and say, I need the truck. And there you go.